to, maybe 35 degrees or something like that. Their efficiency just goes to shit. God damn it, phone.
When the sun hits hard and the day turns mean, house feels hotter than a July dream. Pick up the phone, you know who to see. Call Wrangler AC. Wrangler AC will...
Talking about 69 is 4 inch inside.
Yeah.
They put out 100% of his heating capacity. This fucking dude. Turn that fucking phone off. Yeah. See the shit I gotta put up? Right. Everybody's a comedian around here. These units, they have an amazing capability of heating even when the outdoor temperature is very, very low. I mean, well below zero, these things will provide heat. And obviously that is due to the type of technology that the condensers use, the inverted technology, right? And that's what allows these units to be so efficient in cooling and in heating. Even in cooling mode, like right now in the summer, I believe this one right here is 16 tons, 8 tons and 8 tons right here, right? And they're controlled by one thermostat. You see the thermostat right here. But this thermostat obviously is here for us to operate the unit, but the reality is they have their own app that they can actually, they never have to come up here in order to gain access to the thermostat. They do everything from a tablet, from an iPhone, a smartphone, or a laptop, right? They can control this thing from anywhere. And the beautiful thing about these units is that when they meet set point, they don't really shut down. I mean, they can if there's nothing else for them to do, but what they do is they do their own calculations, and they see how much cooling power it needs in order to just maintain the temperature. So instead of your temperature, going up a degree, dropping a degree, up a degree, these units don't operate like that. They maintain that set point, and they can slow down to a crawl. I mean, if this thing is let's say it's a 16-ton unit, I mean, if it has to slow down to maybe a couple of tons, it will do that. Which is really, really low. And it responds to the load. I mean, if the space gets harder, okay, it's gonna ramp up a little bit more. So it gives you exactly what you need at that particular moment in time, and that's what makes them very, very efficient. Marvel of engineering, man.
Started right
Yeah,
here?
yeah. Maybe it's 1/4. What is?
San Antonio, tacos hot, but my gas is done. Fast, honest, cool, that's how we roll.
Yeah. Trying to get as close to the finish line as we can.
In the efficiency world, it's comparing, let's say, a 1985 Chevy to a freaking Tesla, man. These things, when it comes to efficiency, there's nothing right now at least in the commercial world, that competes with these things. These things are insanely efficient, and the system that they had before required a boiler, obviously, to provide heating, right? The old heat pumps would lose efficiency after the outdoor temperature reaches a certain degree, right? It's usually right between 30 and 35 degrees, and the efficiency on a standard heat pump just goes to hell. And that's why in commercial applications like this, it is common to use either electric heaters, heat strips, which are very inefficient, or a boiler, which is better but not that efficient. A VRV system, which is what this is, right? That heat pump can easily operate well below zero, and it's still gonna put out quite a bit of heat.
It's hot out here. San Antonio heat. Call the Wranglers up, we gon' make it breathe. Look, thermostat climbing like it's trying to touch the sun. Ceiling fan spinning, but it
It's all about the details, man. Here we're giving added support for the ducts, right?
but it barely getting done. Kids in the hallway, everybody feeling weak. You with Wrangler AC, we pull up in the week. Nah, same day. Big truck in the driveway, boots hit the curb. We ain't here just a side play. Snap back low, toolkit like a
We are replacing the whole coils on this unit right here. It's a big job, especially when you're doing this in a Texas weather.
Yeah. It's a coil swap. So condenser coil. The first guys that came out was another company, and they found a leak. At a pretty common spot. It was one of these straighter coils, and they like those bike valves on the bike tire. So they found one of these leaking. They swapped it out. It leaked out all again the next day. We ended up pressure testing and finding another leak on the coil. It goes here in this corner. We have bubble tested and found the leak right there. After we pressure tested, we throw bubbles and it reacted. So today we're gonna dismantle this whole thing, take the top off, take the doors off, take the sides off, uninstall the coil, and slap the new one in. Right now we're just gonna take out and recover whatever's left in the system so we can start cutting the coil out.
Leave the face up.
Yeah, you can start taking off all the screws. This piece on the, this corner piece we're gonna have to leave on. But these sides you can take off.
hot day, South Texas, sun burning up the block. Thermostat climbing higher, sweat dripping off the clock. Call the crew, we pull up fast. Tool bag in the back, we don't slack. Flip that switch, feel that blast. Cool air rushing through the track.
Pretty awesome, right?
It is gonna be super simple. The only thing holding this to the unit is these two spots right here. So we're gonna just sweat these out. As soon as we got them loose, rip it out, because that side is just held on by, I guess, pressure from the top. Yeah, this whole piece right here. It's loose, right?
Yeah, it's loose over here. It's just,
Watch out there. Oh, yeah. All right. So we'll just put it up against the wall over there. And then we got new pieces of this. So you're gonna grab that piece there. All right.
you want to grab this side?
Yeah. All right, hold it right there. I'm gonna need you to put pressure from the top of the coil.
Down.
Yeah. Yeah, just like that. Okay. All right, you ready, dude?